Assalamu alaikum and good evening, everyone. Today we are going to start October-November 2023, paper 5-2. Let's start with question number 1. Thermometric titration can be used to determine the standard enthalpy change of neutralization. Okay. The maximum temperature reached in the thermometric titration occurs at the point of neutralization between an acid and an alkali. So it means whatever the maximum temperature we get on the thermometer, at that temperature neutralization occurred completely. Okay. The diagram of the apparatus used in figure is shown in figure 1.1. Okay, we have a burette, a thermometer, a polystyrene cup containing a 25 centimeter cube hydrochloric acid and a stirrer. Okay. A student uses the following method. So that is very important. You have to read the and understand the method very carefully and follow it as well. Okay. Neutralization is a reaction when an acid and a base reacts. The titration we do, it's a neutralization reaction, but here we are doing a sort of a neutralization, but without indicator. Instead, we are going to note down when the temperature get the highest point, and after that it start falling down, shows us that there the neutralization occurred completely. Is this clear, Hassan? Now, step 1. Transfer 25 centimeter cube of 1 mole per dm cube hydrochloric acid to a polystyrene cup. Okay. Place a thermometer with a 0.2 degrees Celsius division into the HCl in the polystyrene cup and leave it for 3 minutes. Record the temperature. Okay. Now my screen is stuck again. Add 5 centimeter cube aqueous sodium hydroxide from a burette. Stir and record the temperature of the solution in the polystyrene cup. Okay. One minute, please. Okay. Immediately add another 5 centimeter cube of sodium hydroxide. Stir and record the temperature of the solution in polystyrene cup. Okay. Now, step 5, repeat step 4 until there is no further increase in temperature. Once the temperature start to decrease, repeat step 4 3 more times. The student obtains the results shown in table 1.1. Yeah, I don't know the net is the connection. There is a problem in the connection. That's why I think I'm lagging. So the method is clear to all of you. Okay, now you need to keep the method in the mind. The method examiner provide you. Otherwise, whenever you got confused while answering any part, go back to the method and read it again. Okay. Now, here we got the results. Now, what they are saying, plot a graph of temperature y-axis against volume of sodium hydroxide added x-axis on the grid using cross to plot each data point. Draw two straight lines of best fit, one for the rise in temperature and one for the fall in temperature. Extrapolate the two lines so they intersect. Okay. Use the graph to determine the maximum temperature change of the mixture. Assume the initial temperature of sodium hydroxide is 18.8 degrees Celsius. Maximum temperature change of the mixture that we have to find from the graph. Okay. Use your graph to determine. Okay. So these are the rest of the steps. First, make the graph. Okay. Okay, so here we have a values. At zero volume, temperature is 18.8. Okay, so 18.8 must be this line, right? Then at 5, it's 21.3. So 21.3 is this line. Then at 10, it's 23.8. So 23.8 is this point, right? Then at 15, 26. So 26.4. Then at 20, 27 point. So at 20, 27.4. So 27.4 must be this. Then 25, it's 26.2. So it is going to be this. Then at 30, 25.1. So 25.1 is going to be this. Then at 35, 24. So it's 24 over here. And then at 40, it's 23.2. So 23.2 is this point. Okay. So see what they are saying, that you need to draw the two line of best fits. Okay. So if I am not wrong, we are getting one best fit over here. And let me see, 25.1, 24, 23.2. It is going to be like this. Okay. So now let's read. Use your graph to determine the maximum temperature change of the mixture. Assume the initial temperature is 18.8. Okay. So what is the maximum temperature raise we got? Yeah. because all the other points are getting on the line, so that's why I ignore it. Otherwise, there will be difficult to make the line of best fit. Yeah, the screen is frozen as well. 1 minute. Yes, but see the all the other points are, on the line. It's again. Okay. So if you see the temperature over here, it's 27 point. It is almost 27.9, right? So it is going to be 27.9 minus 18.8. Can anyone tell me the value, please? Is it 10.1 or 9.1? 9.1, right? Okay. Now next part. Use your graph. Use your graph to determine the volume of sodium hydroxide needed to neutralize 25 centimeter cube of 1 mole per dm cube hydrochloric acid. So see, the maximum, the volume of sodium hydroxide needed will be yeah, it is 16, 17, 18. It is 18, right? So 18 centimeter cube of volume of sodium hydroxide is needed. 18.0. Okay. Use your answer to 3 to calculate the concentration of sodium hydroxide in mole per dm cube. Okay. So we know the concentration and volume both of hydrochloric acid, and we don't know the volume. We just know the volume of sodium hydroxide. See, we have extrapolate means that we have extended the two lines. Otherwise, your one line is going to be end over here and the other line is going to be end over here. So we extrapolated both of them. And as a result, this we get this point. Okay, so that's what extrapolate means, to get to know where the actual both the which will be the highest point. Okay, so volume and concentration of hydrochloric acid are given. So we are able to find the moles of hydrochloric acid. Its volume, its concentration is 0.100 times its volume, which is 25 divided by 1000 to convert it into a dm cube. Can anyone tell me the answer, please? It's 0.0025. So we know the ratio of HCl and NaOH. Their ratio is going to be 1:1, right? So 0.0025 is to x. So x is going to be 0.0025. Now we got the moles of sodium hydroxide. Now we have to find the concentration of sodium hydroxide. So its moles are 0.0025 and the volume is 18 that has been used. So 18.0 divided by 1000 to turn it into decimeter cube. You don't know the reaction between sodium hydroxide and hydrochloric acid. It is always 1:1. Sodium hydroxide and hydrochloric acid always react in 1:1. Can anyone tell me the answer, please? Make the equation of NaOH and HCl. See, we know acid and base reacts to form water. So Na is a +1 and chloride is a -1. So when you make the formula, it's NaCl, right? So see, the equation is balanced. But for example, if you react the sodium hydroxide and the acid would be, instead of hydrochloric acid, it's sulfuric acid. So the salt would be Na2SO4 and H2. And now if you balance the equation, you have to put 2 over here. So the ratio of a sulfuric acid with NaOH is going to be 1:2. Okay, so we are getting the answer 0.139 mole per dm cube. Is this clear? Yes, that is the answer. 0.139 dm cube. Okay, now suggest why a titration using an indicator is more accurate than a thermometric titration. Uh, Obviously, it is because that the endpoint shows a color, right? And it occurs instantly at a drop. The endpoint color change is instant. Okay. Now, suggest a suitable piece of apparatus for transferring 25 centimeter cube of 1 mole per dm cube HCl in step 1. So I think it's understandable to all of you that we are going to use volumetric pipette, right? Yeah, burette can also be used, but see, whenever you are doing the titration, the first thing has been added by pipette, that is a 25 centimeter cube. And the other one we are adding with the burette, right? Determine the percentage. Okay. Determine the percentage error of the measured temperature increases when 5 centimeter cube of NaOH is added. Show your working. Okay. So determine the percentage error of the measured temperature increase when first 5 centimeter cube of NaOH is added. Okay. So when we have added first 5 centimeter cube, how much the change in temperature? Can anyone tell me, please? 13 minus 8 gives me 5. 20 minus 18 gives me 2. So it's 2.5, right? So the change in temperature is 2.5. So the total temperature change is 2.5. Obviously multiply by 100. And see, this temperature is actually a change in temperature, right? So it means it is taken by the two readings, by dividing the two readings, by subtracting the two readings, right? So it means we use the temperature to thermometer twice. Is this clear? So if we use the temperature thermometer twice, so the error must be twice. So if you see, its division is 0.2. So the least count of thermometer is going to be 0.2 divided by 2. The least count is 0.2, so it's divided by 2 gives me the uncertainty, which is, sorry, it's not least count, it's uncertainty. So that is the error in our reading, right? And we use the thermometer twice. So it means that this 0.1 error is also present in this and in this both. And 2.5 is actually is calculated by subtracting these two. So twice of 0.1 divided by the change in temperature times 100. Can anyone calculate it and tell me the answer? 0.2 over 2.5. 0.2 times 100 is going to be 20. So 2.5 times 4 is 10. Isn't it 8? Yes, thank you, Ahmed. So 8.00 or 8. Okay. Now, the standard enthalpy change of a neutralization is defined as the enthalpy change when 1 mole of water forms from the hydrogen and the hydroxide or acid and alkali. In another experiment, a student finds 22.1 centimeter cube of 1 mole per dm cube NaOH increases the temperature by 6 degrees Celsius when 25 centimeter cube of 1 mole per dm cube. Okay, the equation for the reaction is shown. Okay, the formula, use the formula delta H is equals to minus MC delta T to determine the standard enthalpy change of neutralization in kilojoule per mole. Assume that the mass of 1 centimeter cube is solution is 1 gram. Okay. So we are going to use this formula minus MC delta T. So see, one solution is this one and the other one is this one. So the mass is going to be 22.10 plus 25.00 because both the solutions has been used. And the specific heat capacity is 4.18. And the change in temperature they have mentioned is 6.0. Can anyone calculate it and tell me the answer, please? Okay, just leave this one. We are going to calculate the Q first, the change, the heat energy released or absorbed. Can anyone tell me the value of Q quickly? Okay, no minus sign because 1 minute. Okay, we have calculated the Q. So the value of Q is 1181.269, which means 0.27. Okay, is this clear to all of you? No, it's a change because when change means when you are subtracting the two temperature values, so whether it's in Kelvin or whether it's in temperature Celsius, it is going, the change is going to be the same. Okay. For example, 25 minus 0 is 25 and 298 minus 273 is also 25. So the change would be the same. Now, for enthalpy change, the expression is minus Q over N times 1000. So N is the number of the moles. So if you see, there are lesser moles of NaOH. So we are going to take the moles of NaOH. So it is going to be minus 1181.27 over moles of NaOH. So how you will calculate the moles of sodium hydroxide? 1.00 times 22.10 divided by 1000. Can anyone tell me the moles of NaOH? It's 2. I remembered, otherwise it is given over here. See, You have to remember this formula. This formula is you have studied in your AS level. So we got the moles 0.0221. So 0.0221, and when we keep the 1000 in the new denominator, it turns into kilojoules. So can anyone calculate and tell me the answer, please? It's minus 53.45. What 4.81? I didn't understand, Hussein. So minus 53.523 significant figures. Yeah, it's 4.18. That is C. That is a specific heat capacity. The mass is this. See, they have told you assume the mass of 1 centimeter cube solution is 1 gram. So whatever the total volume of the solution, that is considered as a mass. Which formula, Mahveen? No, there is no need to convert it into kg. This one you have studied in your AS level. These two both. Check the notes from AS, you will find them. Now, part E, the theoretical value for the standard enthalpy change of neutralization reaction between hydrochloric acid. Yes, Azif. No, it's minus 57.6 kilojoule per mole. Okay. Give one reason why the value you obtained in D differ from the theoretical value. Okay. So the obvious reason over here is that heat loss to the surrounding. And just give me 2 minutes, please. Heat loss to the surrounding. Sorry. No, you can't write that because, obviously, whether the conditions are standard or not, there must be some heat loss when you perform the experiment, right? Okay. Just give me a minute. It's stuck again. Yeah. Okay. Now, next part. Suggest why the standard Suggest why the standard enthalpy change of neutralization determined using ethanoic acid is less exothermic than the standard enthalpy change of using hydrochloric acid. So that is also we have discussed. If you recall, ethanoic acid is an organic acid and all, it's a weak acid, right? So, and its dissociation is partial, not complete. So to actually to dissociate it more, we need a more energy. So obviously, if the energy is taken in, so the lesser energy would be released. Ethanoic acid is weak acid, ionizes partially, hence energy is needed to ionize it or dissociate it. So obviously, if we are providing some energy and the enthalpy change of neutralization is exothermic, so at the end, when we get the change would be the energy that would, the net energy that would be released would be lesser than the one which is released when the stronger acid is used. Okay. Now, question number 2. A student investigates the rate of reaction when zinc reacts with a dilute hydrochloric acid. The student uses the following method. Accurately weigh 1 gram of a zinc foil, add 5 centimeter cube of a 2 mole per dm cube hydrochloric acid to a conical flask, add the zinc foil to the 50 centimeter cube of HCl in the flask and immediately start a timer. Stop the timer when 20 centimeter cube of hydrogen gas has been collected. Repeat step 1 to 4 using lower concentrations of HCl. Okay. Complete figure 2.1 to show the apparatus that can be used to collect the and measure the volume of hydrogen produced. Label your diagram. Okay. So over here, there must be an acid and there must be as they have foil of a zinc. Here I put a bung and then a tube. And that tube is going to be connected to a gas syringe. So zinc, HCl, conical flask, bung, gas syringe. Okay. Yeah, it's a hydrogen gas, so you can collect it over high water displacement method as well, right? Okay. The student wants to perform a similar experiment using 0.1 mole per dm cube hydrochloric acid. Describe how the student should make a standard solution of 250 centimeter cube of 0.1 mole per dm cube starting from a 2 mole per dm cube hydrochloric acid solution. So see, it's a stock solution and it is the volume and the concentration of diluted solution. So if you recall, I have discussed the formula with you that C1V1 is equals to C2V2, where C1 and V1 are the concentration and the volume of the stock solution. So the concentration of a stock solution is 2.00 and the volume I don't know. Sorry, it's going to be V2. The concentration of a diluted solution is 0.100. The volume that I need is 250. So the value of X is going to be 0.100 times 250 over 2. Can anyone tell me the answer? Is it 12.5 centimeter cube? It again is stuck. 1 minute, I am sharing back. So see, from this expression, we are able to calculate the volume of the stock solution having a concentration of 2 mole per dm cube, that we need 12.5 centimeter cube of that solution. Is this clear now? So 12.50 centimeter cube of 2 mole per dm cube hydrochloric acid is transferred to 250 centimeter cube volumetric flask by using burette, right? Because it's 12.5, so we can't measure it in a pipette. And for accuracy, we need either burette or a pipette. Fill the volumetric flask up to the mark with distilled water and mix well. Is this clear to all of you? The student carries out further experiment using higher concentration of HCl. The student wears chemically resistant gloves when using 6 mole per dm cube hydrochloric acid. Suggest why. So see, it's a 6 mole per dm cube. So all it's a acid. So acid is already corrosive. So it becomes even more corrosive. Higher concentration make it more corrosive. Is this clear to all of you? Now the student obtains the result shown in table 2.1. In these experiments, 1 over T can be considered to be the proportional to the initial rate. Okay, so it means they are saying that 1 over 2T is proportional to the initial rate. Okay. Complete the table by calculating 1 over T for each concentration. Give your answer to 3 significant figures. So you are going. Okay, Mahveen, the first one is 0.0640. Let the screen share. Okay. Let it share. It's not sharing. I don't know. Let me share again. Okay. So first one is 0.0640. 0.096. After 96, what is the next number? It's two significant figure, Mahveen, not three. Then 0.128. Okay. Yes. After zero, is there any other figure? 0.0960. Yes, Maveen, after 0, is there any other digit? Yes. Okay. 1 minute. 1 divided by 10.41. It's 9606. So it is going to be 0.0961. Okay. Then we have 1 divided by 6.25. It's 0.160. And 1 divided by 5.24. It's going to be 0.191. Okay. So we got the readings. Now use your data from table 2.1 to produce a sketch of a graph. Produce a sketch of a graph of 1 over t against concentration in 2.2. It is not necessary to include a scale on the axis table, the sketch line A. Okay. So you have to sketch a graph, right? So if you see that when the concentrations are getting, so if you see the concentration is increased by 1.5, by which factor it is increased? Can anyone tell me, please? No, just divide 0.0961 over 0.0641. I don't know. Again, screen is stuck. Yes, see this is increased by the factor of 1.5. So can anyone tell me by which factor it is increased? 0.0961 divided by 0.0640. So it is also 1.5. So see, they are almost uh, increases with the same factor. So it means how many data points we have? 1, 2, 3, 4, 5, right? So you are going to do like this: 1, 2, 3, 4, and they are increasing by same factor. So actually you can do this the easiest way: 1, 2, 3, 4, 5. Okay, because if you further check, you will find that they are increasing their concentration and the time, both are increasing with the same factor. Okay, so it is going to be like this. Okay, what they are saying? Okay, they ask you to label this line A. On a figure 2.2, sketch a second line to show the graph of concentration against 1 over time if the powder zinc is used in the experiment instead of zinc foil. Yeah, the reaction will be faster, obviously, and this line would be like this. Is this understandable to all of? Now, using your data table in 2.1, reduce the rate of reaction between zinc and HCl. So, here we have a concentration of HCl is getting changed, right? And we see that these two are getting changed with the same factor, which means that the order is going to be first order. And so that we are going to write that rate is equals to rate constant K times concentration of hydrochloric acid raised to the power 1. Is this clear? Yes, if any one of you has any confusion till here, please ask. Okay, Shahan. Okay. At higher concentration than those shown in table 2.1, significant temperature increase occurs, suggest how line A in figure 2.2 would be different at those higher concentrations. Explain your answer. Okay. So if we see, they have told you for a line B SN that you have used zinc powder instead of a zinc foil. So if there is a powder, yes, Maham, it's in zero order. If it's a powder, so what happens to the rate? Due to the surface areas increase, the rate of reaction increases, right? Okay. Now, what they are saying that the temperature is going to be increased when the higher concentrations as shown in table 2.1 are shown. Suggest how line A in figure 2.12 would be increased at a higher concentration. So see if the concentration get higher, then what happens to the temperature? They are saying that the temperature is also getting higher, right? So the line would not be going to be stay straight, but it becomes a curve like this because the temperature is getting higher, and as a result, the reciprocal, the time which is taken is also getting very smaller. Why low temperature? They are saying that the temperature are increasing, right? Actually, if you see over here that the concentration is if increasing, the time is also getting lesser with the same, factor, or the change by which by the factor there is a change in concentration, the same factor it's changing. But if you see At a higher concentration, what they are saying, if you read this, that if you use even more higher concentration, there is a significant increase in temperature. So if you see that the higher concentration would increase the rate, right? But what temperature increase would do? It is also going to increase the rate even more. So the rate would increase even more, and that's why you are getting the curve like this. I'm not, see, it's going to be like this because the rate is increasing due to the increasing temperature as well. So it's not going to be stay the same. It is not going to be increase with the same, but with the higher rate. That's why. So at higher concentration, the line turns to form a curve towards upward as the rate increases due to temperature increase. Is this clear? Now, suggest one way in which the temperature increase may be minimized. So if you put the reaction mixture in the water bath, it will lose the energy, lose the heat to the water bath, and as a result, that the temperature uh, increase is not that much. Okay. Now E. The zinc foil has an oxide layer. Suggest how the oxide layer can be removed before weighing the zinc. So it's very easy. You can always use a sandpaper. Use sandpaper to remove it. Now, if the student does not remove the oxide layer, the initial rate of a reaction is lower. Then that should be obviously because the oxide layer is there. So it will dilute the solution. So the concentrations would change and you are not going to do the calculations properly. Explain why the initial rate of a reaction is lower than it should be. So the thing is that if the layer is not removed, so there is a zinc oxide, right? Zinc oxide does not react with acid to form hydrogen gas. See, because initially the reaction would occur, the salt and water has been formed, but we are not getting any gas. So the gas would form after the zinc oxide layer has been reacted and used up from the metal surface. Is this clear? If anyone of you has any confusion till here, please ask. Otherwise, we have done with the paper. So I suggest you for tomorrow's paper, just stay calm and read the question very carefully so you didn't miss anything that has been asked by the examiner, and just do the paper with the uh, don't, panic in the exam. So you are able to do it well, inshallah. Okay. So best of luck for tomorrow. Take care, everyone. May Allah give success to all of you. Allah Hafiz.